%80 of earthquakes worldwide occur around the Circum-Pacific region, chiefly along the subduction zone boundaries, known as the Pacific Ring of Fire. It's so named because of the more than 400 active volcanoes that occur there. The earthquake and volcano belt sweeps through Japan, where about 20% of worldwide measured earthquakes occur. There are more than 100,000 earthquakes recorded in Japan every year, and of those, about 1,500 are strong enough for people to notice. By examining the pattern of seismic activity of all earthquakes greater than magnitude 4 since 2011, we can see the expected patterns of shallow to deep earthquakes along the subduction zones. Over 100 major earthquakes of magnitude 7 or larger have occurred in the past century. Japan also has over 100 active volcanoes along a volcanic arc that lies parallel to oceanic trenches. Both of these are distinctive features of convergent margins. Earthquakes, volcanoes, and trenches all result from Japan being wedged among 4 major tectonic plates. The Pacific Plate subducts beneath the Okhotsk Plate at the Japan Trench. The rate of convergence is 8.3 centimeters per year at the location shown. The Philippine Sea Plate subducts beneath central and southwest Japan at the Sagami Trough, the Nenkai Trough, and the Ryukyu Trench. At the location shown, subduction is somewhat oblique at 4.5 centimeters per year. A complex structure accommodates slow east-west convergence between the Okhotsk and Eurasian plates. Northwest-directed forces due to subduction, plus east-west oriented compression between the Eurasian and Okhotsk plates, complicate the region. Let's go back millions of years and exaggerate the tectonics. Now we can see the oblique subduction pushing a four-arc crustal block to the west at the rate of about 1/2 centimeter per year. A right lateral strike-slip fault, called the median tectonic line, accommodates most of that motion within the Eurasian plate. In this region that includes Kyoto, the imperial capital of Japan for more than 1,000 years, the earthquake history since the mid-1800s demonstrates that major crustal fault earthquakes in this region occur about every 15 years. The most recent example is the Great Hanshin earthquake of 1995, more commonly referred to as the Kobe earthquake. Before dawn on January 17, 1995, a right lateral strike-slip fault ruptured 20 kilometers to the southwest and 30 kilometers to the northeast from a hypocenter at about 15 kilometers depth. Fault displacement was 3 meters at the hypocenter and 1 meter at 10 kilometers depth beneath Kobe, a port city with population of 1.5 million. Although this magnitude 6.9 earthquake released less than 1/1000th of the energy released during the 2011 Tohoku subduction zone earthquake, severe ground shaking and resulting damage was concentrated at locations underlain by weak, water-saturated sediment and artificial fill along and within Osaka Bay. Traditional style houses with a heavy clay roof tile were vulnerable to collapse, while failures of individual stories or the entire structure affected some multi-story buildings. Hundreds of fires ignited, and firefighting efforts were hampered by failures of the water supply and transportation system. Over 100,000 buildings were destroyed, leaving 300,000 homeless. Sections of the elevated Hanshin Expressway that opened in 1962 collapsed, but most structures completed after 1981, when building codes were updated, survived with minimal damage. This earthquake forced a reassessment for all tall buildings and transportation infrastructure. Now, let's look at cross-sections of the subduction zones. In northern Honshu, the oceanic Pacific Plate dives beneath the continental Okhotsk Plate. Here, we see how earthquakes outline the subduction geometry. To 70 kilometers depth, thrust faulting earthquakes are concentrated at the contact between the plates where megathrust events, often associated with tsunamis, are generated. Deformation of the overriding plates generates shallow intraplate earthquakes. Below 70 kilometers depth, earthquakes occur only within the subducting plate. Earthquakes in this subduction zone reach extreme depths of over 500 kilometers because the Pacific Plate is about 150 million years old and therefore very cold when it starts to subduct. Plus, The rate of subduction is fairly rapid at over 8 centimeters per year, so the oceanic plate is still cool and brittle at depth. A cross-section through central Honshu shows a slightly steeper subduction angle, thus the volcanoes are closer to the trench. At the Ryukyu Trench, the angle of subduction is similar to central Honshu, but the subduction rate is slower, and the max depth of earthquakes is only 300 kilometers. By the late 1800s, written accounts in the beginnings of seismology provide reasonably accurate information on the location and size of earthquakes off the northeast coast of Honshu. Running at 5 years per second, this animation shows the earthquake history of magnitude 7.4 or larger earthquakes on the subduction zone boundary between the Pacific and Okhotsk plates from 1896 through 2010. This history led to the impression that earthquakes on this plate boundary do not exceed magnitude 8.2. That maximum earthquake magnitude and associated tsunami size became the basis for emergency management, including coastal tsunami defenses. Some geoscientists observed that the displacement between the Pacific and Okhotsk plates during earthquakes of the past few centuries was much less than the relative plate motion. They were concerned the subduction zone might be storing elastic energy over many centuries that could be released in a massive earthquake. On March 11, 2011, the Tohoku-Oki magnitude 9 earthquake ruptured a 500-kilometer-long by 200-kilometer-wide area of the plate boundary over an interval of 3 minutes. Extreme ground shaking affected coastal towns of northeastern Honshu, and strong shaking lasted for 6 minutes in Tokyo. Superior construction practices and earthquake preparedness impressively mitigated damage from ground shaking during this earthquake, confirming that Japanese cities often shake but rarely topple. Unfortunately, the tsunami generated by the Tohoku earthquake reached greater heights and much further inland than had been anticipated for tsunamis in this area. To understand the 2011 tsunami, let's view the earthquake rupture process in cross-section. Rupture initiated at the hypocenter, 24 kilometers beneath the seafloor, and then propagated both up-dip to the east and down-dip to the west. Maximum fault displacement reached 40 meters at a location 50 kilometers from the Japan Trench, and then decreased to 20 meters at the trench. These are the largest fault displacements documented for any earthquake in history. Elastic rebound during the earthquake caused stations along the coast nearest the epicenter to jump east by as much as 4.4 meters, or 14.5 feet. Seafloor uplift reached 7 meters above the zone of maximum fault displacement, while the seafloor dropped by 2 meters between the epicenter and the coast. Much of the coastal area subsided during the earthquake. That vertical displacement of the ocean floor produced the tsunami that rushed onshore within 20 minutes of the earthquake. In coastal areas where seafloor bathymetry and onshore topography focused wave energy, the tsunami reached elevations of 40 meters, or 130 feet above sea level. Although 96% of citizens successfully evacuated the tsunami inundation zone, nearly 20,000 lives were lost in this, the most costly natural disaster in Japan's history. Centuries of written accounts from this region report earthquakes and tsunamis, but gave only vague hints about past events as large as the 2011 event. However, a decade before, geoscientists searching sedimentary layers upslope of the coast reported tsunami geology evidence for a similar earthquake in 869 AD. Unfortunately, debate about this tsunami geology was still ongoing when the 2011 earthquake and tsunami struck. This painful lesson taught us that the subduction zone between the Pacific and Okhotsk plates, and probably others worldwide, can store elastic energy over 1,000-year intervals and then release that energy in just a few minutes during massive earthquakes. As towns in northeast Honshu devastated by the 2011 tsunami are being rebuilt, changes in coastal land use practices are being implemented to decrease the number of people living and working in vulnerable nearshore areas. In this and many other ways, Japan continues to advance earthquake and tsunami preparedness.